Now, let's look at W0. Since we already solved W1 in terms of x and y, we can just substitute that expression into the equation for W0. It looks complicated, but we can simplify it a bit using sigma notation. Even then, it's still a bit complex, but let's go through it. If we look at the denominator, we can see that it's proportional to the variance of x. Now looking at the numerator, the first term reflects the mean of y, and the second term reflects the covariance between x and y. So what does this mean? W0 represents the average level of the dependent variable. In this example, the average house price. It sets the baseline of y based on the data, and then considering the correlation between x and y, house size and house price, it adjusts the line so that it passes through the data on average. In other words, the intercept, W0, shifts the line up or down to minimize the MSE. Let's make it more intuitive. The optimal W0 is the value that sets the partial derivative with respect to W0 to 0. If we rewrite the derivative in terms of y hat, what does it mean? Think about it. It's the average of the residuals, the errors, and it equals 0. In other words, the moment we find the optimal intercept W0 that minimizes MSE, the mean of all the prediction errors is automatically 0. Graphically, if we input the mean of x into the regression model, the predicted y hat will exactly equal the mean of y. The intercept ensures that this property holds, adjusting the regression line up or down as needed. If you reflect on this for a moment, it makes intuitive sense.